Hi, so in this video we are going to learn how to do stoichiometry calculations. By definition, stoichiometry means predicting the amount of substance either required or produced in a reaction. Stoichiometry is also the theoretical yield. You are calculating in theory how much water should be produced if you put so much of these reactants in, or you are calculating in theory how much reactant you need if you want to produce so much water. So for stoichiometry, you need a balanced chemical equation. If your equation is not balanced, you should balance it, as well as the numbers that you need to have, the numbers need to be in units of moles before you can convert from one substance to another. So you can't convert from hydrogen to water, for example, if you're given grams. You need to convert from grams to moles, and then you can convert from hydrogen to water. Stoichiometry is always done in units of moles. And we are going to set it up in this basic format that we should be familiar with at this time of the year. So our first example, how many moles of water are produced when 1 mole of hydrogen reacts with excess oxygen gas? Alright, so we want to set it up this way, and these numbers in our fraction are going to come from these coefficients out front. For every two hydrogens and 1 oxygen, it produces 2 waters. These numbers out front are called coefficients, and these coefficients give us the ratio, the mole ratio, if you will, in determining anything for stoichiometry. Any type of calculation, you will always use a mole ratio or the coefficients. It's really the same thing. We're saying the same thing if I ask you what are the coefficients or what's the mole ratio. So for this problem, we have 1 mole of hydrogen, and it's reacting with excess oxygen gas. That phrase, the excess, all that means is that there's plenty of oxygen gas. That's not going to limit how much water can be produced. So if you are given a problem and it says with excess anything, you can just ignore that part of it because it's not going to affect any of your problem. You are interested in the number. So we have 1 mole of hydrogen. That's what we know. And we are looking to know how much water we can make. That's what we want. So we are going to multiply 1 mole of hydrogen. What we want is water, so H2O goes on top. It's 2. And we know hydrogen. And that number for hydrogen is 2. We're always going to take the coefficients for our fraction when we're converting from one substance to another. So 1 times 2 divided by 2. If we start out with 1 mole of hydrogen, we can make 1 mole of water. Alright, so for our second example, how many moles of oxygen gas are required to react completely with 4 moles of hydrogen gas? So we have 4 moles of hydrogen gas, and we are looking to calculate how many moles of oxygen gas are needed. That react completely bit, it's means so there's absolutely nothing left over. That's all that means. So you really aren't going to do anything different. It's just terminology thrown in to be a little bit confusing, but we'll get to it in another week when something doesn't react completely, what that means. So 4 moles of hydrogen gas, that's what we need to convert. And we want oxygen, so we're going to put O2 on the bottom. We know hydrogens. We know how many moles of hydrogen there are. The numbers come from the coefficients. So it's 1 oxygen to every 2 hydrogens. And now we can solve the problem. 4 times 1 divided by 2. For every 4 moles of hydrogen gas, you can produce 2 moles of oxygen. And that is stoichiometry. It's all about these coefficients and the mole ratios that they can be set up to form.